Okay, today I will show you how to prepare and extract a grid point in in your study area. Depend on your resolution that you want. If you want to extract 0.25 resolution or 1 degree resolution, in all these grid point, we will extract within your study area. And then based on that grid point, we will use that grid point to extract say an IP6 GCM. So I have prepared this code. So you let me share the screen first. So before we prepare grid, prepare the grid, or before we extract the grid for our study area, first you need to have your shapefile. For example, in this study area, I have a shapefile for Peninsula Malaysia. If we look at the Google Map, Malaysia, Google Map. So my study area is here. I want to study area in this Google Map for Peninsula Malaysia only. So make sure that you have this shapefile to extract grid point that you want, so that this shapefile will guide you to extract where you want to extract the grid point. So I will not tell you how to prepare a shapefile. Everybody need to have your own shapefile, but basic GIS uh, if you're for your study area. So for after you have this shapefile, so then we can start prepare the grid and extract the grid for prepare the grid first, and then extract the grid in that is within your study area. So you need the library SF and library ggplot2 for these purposes. So you can run this line, run library SF and ggplot2. If you don't have this library, you can install it, and then set your working directory where you put your shapefile. So my shapefile is here in this folder. So this is my shapefile. So as you can see, my shapefile is MYS@ADN2. So this is the shapefile of this study area, Peninsula Malaysia. So I will load the shapefile here. So this is the name of my shapefile. I put it here, and it is located in this folder. So run the folder, already run it, and then read the shapefile. So and then we check the CRS of the shapefile. This is just optional, just if you want to check. And then I will reproject the shapefile to WGS84 only if necessary. Sometimes when we prepare shapefile, it use a different projection in our GRS or QGIS, but just in case we want to reproject it into a normal one, WGS84. This is we reproject this one, and then we define the range and resolution. For example, this is the most important part of this extracting the grid point, the lat long, because you need this information 1 and 7 for latitude. You need to have a box here, a box in your study area. What is the location of this? You can see down here. Okay, I put it here. Okay, or this. Okay. You can see I put the box is 127 down here. If I put down here, so I need to make sure that the box of this one is within 17 and 100 and 104.5. So this one just now is 99, 100 until more or less 104. So it will be the box here for Peninsula Malaysia. And then if you want resolution 1 degree, you can change this by 1 degree. But if you want 0.25, 0.25, because a lot of gridded dataset. Now they have 0.25, 0.5, and 1 degree. It's up to you. But in this case, I will use 0.25 degree. So define the range and resolution first. This is kind of manual. You see the map here because different study area will have different range. So now we create a grid of latitude and longitude. Let me see. We can view this one, I think. This is all the box grid. This is not the extracted grid. You see 475 grid here. So it is all the grids within this study area. But we don't want all that grid. We only want the grid inside the Peninsula Malaysia. So now we convert this grid to an SF object by using this code set as SF, and then we extract points within the Peninsula Malaysia by using this Peninsula Malaysia shapefile just now. That's why that is very important to have your own shapefile. So now it extract the point. So after that, you can plot the grid point within the shapefile, and this one I use a red plus sign so that you can see the result. So see, it's very nice. This is Peninsula Malaysia. This is my study my shapefile that I use, and then all the grid point that fall within the Peninsula Malaysia will be extracted. So there is about 171 grid point actually within this Peninsula Malaysia compared to 400, 470 something like just now, what? So we only extract the plot that is within the Peninsula Malaysia. So make sure you have your shapefile. So this is the code that you use. You have shapefile, color black for the borderline, and this right size. You can play around with the size here, size of the this plot. I use this shape 3 because I want to use this plus sign, but you can change this to black maybe it will be nice, I don't know, something like this, but it's better if I use maybe blue. You can play around with the code here to change the color and change the size. The size, if you put very big, and the plus sign will be also very big, so it's not look very nice. So you can put 2.5 maybe sufficient. Okay, now it looks sufficient. Now all this grid point is there, and then uh, we save that this grid coordinate into CSV file. Point within set coordinate as CSV file. So now we have this. We put this as 2. So this is our shapefile. So we have left long, and this is long, this is left. So this is all 171 grid point that is located within Peninsula Malaysia. So based on this grid point, now we use this grid point to extract CMIP6. This is actually this tutorial is already there, but you can repeat here. So for example, we want to extract rainfall monthly from CMIP6. So you can download first any model from CMIP6, but I will go through quickly. So the library here we have GDAL, NetCDF4, master, ER input, and SP library. And then run the memory. I don't think you need this one. And then use the grid point that you have just now. But for this case, with the grid point, actually you need to rearrange the grid point into something like this. Actually, the first column is left, the second column is long, and then put a grid number 1 until 171. So easily can be done because the output just now you have long left, right? But you just rearrange everything to let long grid. This is for expecting CMIP6. So now based on that grid that you have, you read this grid, this grid, and then you go to your CMIP6. So our CMIP6 is here. I have, for example, here we have Thai ESM1 monthly rainfall. So I will go to this folder and I read this file. That file. And it will read this netcdf file because we want to extract uh, rainfall based on the model Thai ESM1, and we will use bilinear interpolation to regrid that Thai ESM into 0.25. Why 0.25? It is based on our prepare grid just now. So our grid is 0.25, then it will be grid based on the grid that we prepare. If you want your to extract the CMIP6 to into 1 degree, you can prepare 1 degree by using the first code just now when we prepare the grid or extract the grid for your study earlier. Okay, now after you get the NC file or that one, you can extract data from netcdf. Okay, here. This year you will do bilinear interpolation. So you can see in the method here we use bilinear interpolation, but you can change the method for interpolation. It's up to you. You can do another study where you compare uh, how is if the interpolation is which interpolation method is the best for extracting CMIP data. So you can extract this by using bilinear interpolation. You sample it and then you can run all this code easily, and then it will extract your TISM1 rainfall monthly data into 0.25 degree with resolution. Now it's already run. Now we extract it into CSV. So here we have rainfall. You must convert it into ML by using this code times 259 200 with 2 decimal places. You times with this value, because I have some student asking me why the value CMIP6 is doesn't make sense, because it doesn't convert to, you must convert it into first. So you must time it with 259 2000. So then it will turn into millimeter, and then we can extract this into CSV file. So this is answer. So now you have 171 grid point based on the grid that you prepare. All the rainfall has been interpolated by using bilinear interpolation from based on CMIP6 data that you download from the website. Then you get all this value rainfall for each grid point within your study area. This is based on the grid point that you prepare just now. Okay, I think that's all. I hope this will be very helpful.